Hello all, this is Dr. Srilatha working as Senior Assistant Professor in the Department of Mathematics in Vallurpalli Nageshwara VIGNANA JYOTHI Institute of Engineering and Technology. Today I am going to discuss about another iteration method, that is Gauss Seidel method. As we all know, the set of system of linear equations in n number of unknowns. We're having this n system of equations, that is a11x1 plus a12x2 plus a13x3 like that up to so on a1n xn, which is equal to b1. And the second equation is given by a21x1 plus a22x2 like that up to so on a2n xn, which is equal to b2. So like that we can write up to n general system of equations here. So here all the diagonal elements should be non-zero so that we can find the number of unknowns. It may be x1, x2, x3 like that up to so on xn. So here again how we will be extracting this number of unknowns here, with the help of this n system of equations we can write x1 is equal to b1 minus a12 x2 minus a13 x3 like that up to so on a1n xn, which is whole divided by a11. Similarly we'll be calculating x2 here like that up to so on xn from third equation. So here our ultimate guess, that is we need to do some initial approximations, we need to do some initial guesses here. We need to rewrite the equations for solving the number of unknowns x1, x2, x3 like that up to so on xn. So before entering into this Gauss Seidel method, we need to keep in mind one important point, that is we need to use, whenever we are doing the approximations, first approximation we will be taking the initial guesses as x0 equal to 0, x1 of 0 equal to 0, x2 of 0 equal to 0 and x3 of 0 equal to 0. But when we move on to second value here x2, we will be using the most recent value what we calculated in the previous one. So remember to use the most recent value for xi's, which means to apply for calculations remaining which is in the current iteration. What is the difference between Gauss-Jacobi method and Gauss-Seidel method means, in Gauss-Jacobi method we will be not using the recent values, but in Gauss-Seidel method will be whatever the values we are extracting, whatever the values we are finding in the current iteration, the same values we will be using in the next evaluations. So this is the one important that is EAPCET under Gauss Seidel method. So here we'll be having always, we need to keep in mind some conditions here. As we all know here, all the diagonals should be non-zero, so that we'll be extracting the evaluations here. Now coming to the first, how to solve this Gauss system of equations by using Gauss Seidel method. We are having one example problem here. We need to solve the system of equations by Gauss Seidel method. We are having three system of equations, that is 10x plus 2y plus z equal to 9, x plus 10y minus z equal to minus 22, minus 2x plus 3y plus 10z equal to 22. As we discussed earlier in Gauss-Jacobi method, always the system of equations should be diagonally dominated. The same condition should be for Gauss-Seidel method also. So here you are having a11 as 10, it should be greater than or equal to the remaining elements here. And next this is also a22, which is also equal to 10, and this is also equal to 10. So we need to check the conditions whether it is diagonally dominated or not, right? So next we need to extract from these values, we need to extract the value of x, and from this we need to extract the value of y, and that from third equation we need to extract the value of z. So we'll be writing this x as 9 minus 2y minus z whole divided by 10, and y as minus 22 minus x plus z whole divided by 10, and z equal to 22 plus 2x minus 3y whole divided by 10. So in order to find the first iteration values here, we need to take the initial guesses as, we need to take x0 equal to 0, y of 0 equal to 0, and z of 0 is equal to 0. Now, how can I write this first approximation x to the power of 1? I am giving the notation, this is related to first iteration. Now, what is my equation here? 9 minus 2y0 minus z0 whole divided by 10. if I substitute here y naught equal to 0 and z naught equal to 0, 9 minus 2 multiplied with 0, and this is minus whole divided by 10. So these are all equal to zeros, and this is 9 by 10, that is nothing but 0.9. Similarly, I will be calculating this y for the first approximation here. What is our equation here? Minus 22. So just now I inform we need to use the recent value. So here I am having x here. I am using the recent value, that is minus x1. So here x to the power of 1 plus, since I didn't calculated z here, so I am replacing z naught here, which is equal to minus 22. So here I am replacing minus 0.9, and this is z naught as 0 whole divided by 10. So minus 22 minus 0.9. So I can calculate as minus 2.29. Right? Similarly, we'll be calculating the z, the first approximation value. Using this equation, I can write this as 22 plus 2. Just now we calculated 2 x to the power of 1. Just we'll be evaluating now. This is also recent value we will be using here. Y to the power of 1 whole divided by 10. This is 22 plus 2 multiplied with 0.9 and minus 3 multiplied with minus 2.29. So completely you need to use the calculators here. So I'm having my value here. After doing the simplification, this addition and subtraction, multiplication of these elements, I got some value as 3.067. So this is the difference between the Gauss-Jacobi and Gauss Seidel method. We will be using the recent values here. So I got some values here, just I calculated. So this is the first iteration values. I got it here, that is x1 equal to 0.9, y1 equal to minus 2.29, and z1 equal to 3.067. Now I will be calculating the second iteration value, which I calculate as x to the power of 2, which is equal to, my equation is given by 9 minus 2 y to the power of 1, that is first iteration values I need to use here, whole divided by 10. So here 9 minus 2 multiplied with minus 2.29 and minus 3.607 whole divided by 10. So I will be, after calculations, I will be getting the value as 1.0513. Right? Next, y to the power of 2, second iteration value for finding the value of y here. So my equation is minus 22 minus x. Since we are having x here, I am using the recent value, that is x to the power of 2 plus z to the power of 1 whole divided by 10. So minus 22 minus, what is the value? I got it for second approximation here, 1.0513 plus the z value I need to calculate is, that is 0. So just no previous value I need to take it here, 3.067 whole divided by 10. So after calculation, the addition and subtraction of these elements, I got the value as minus 1.9984. So next, to calculate the second iteration value for z here, that is 22 plus 2, the second iteration value for x, and minus 3 y, the second iteration value of y whole divided by 10. That is 22 plus 2 into, so what is the value I got it for first second iteration value? 1.0513 multiplied with 2 minus 3 is multiplied with minus 1.9984. So we are using the recent values, which gives, when compared to the Gauss Jacobi method, this Gauss Seidel method, for small for less number of iterations, we will be getting the more accuracy values here. So after these calculations, I got this value as 3.0098. So these are the second iteration values, I got it here. In the similar manner, we can do so many iterations here. Just now we completed the first iteration values. I got it this second iteration values. Based on this second iteration values, we need to do this third iteration values. So if you observe here, a third iteration x1 values here you are having 1.0513 and this is 0.99. And this is minus 1.99 and this is minus 2.0 and this is 3.00 and here this is 3.0. So since the values are not approximately equal here, we are going for another iteration for getting the more accurate values here. So similarly, we'll be doing the fourth iteration, and similarly we'll be doing the fifth iteration values here based on the previous iterations. If you observe here, we got it here, both the values here. This is 1 and this is -2 and this is 3. So exactly. So when compared to the Gauss Jacobi method, we will be getting more number of iterations, might be equal of for 7 and 8 iterations. But for Gauss Seidel method will be stopped up to only 4 and 5 iterations. So this is more, this method is which gives the more faster when compared to the Gauss Jacobi. So here we can conclude that both iteration 4 and 5 are nearly same. I can stop the procedure here. So this Gauss Seidel method will give the more accuracy and it is more faster, which is converging to the number of unknowns here. I hope you understood this procedure, how to calculate the iterations with the help of the calcs and with the help of the recent first iteration, second iteration values. So that we'll be getting, for small number of iterations, we'll be getting the more accuracy values here. I hope you understand this Gauss Seidel method. Thank you all. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.